Hi, it's Mr. Bennett here. Today I'm just going to go through the Twin Peaks or Tri-Peaks investigation for you. If you want to sort of follow through, I'll sort of explain to you what you need to do. Obviously, keep in mind you need to keep looking at your performance standards to see that you're giving yourself a chance of getting an A. So essentially, in this particular investigation, you're looking at connecting initially two peaks and then the third peak. All right. So, and we're putting a gondola or a gondola between two mountains. All right. So, obviously, you could drive between the two mountains, but feasibility, it's much more enjoyable for the skiers to be able to ski, on one particular mountain or another mountain on the day, and you want that to be a quick access rather than a tedious thing to do or expensive thing of obviously using a helicopter. Now, here we have some information, some survey information. So we're basing this on a survey. Your birth month that you need to choose. So I'm born in June, so therefore my number I'm going to be using is 6. Okay, so I'll put 6 there. When I start looking at the calculations, okay, so the first thing that you're doing over here is from point A, your angle of elevation is going to be 9 plus your birth month, so 9 plus 6 is 15 degrees. Alright, is what I'm going to use there. And then the other one's going to be 11 plus your birth month, which is going to be 17. Right, then you're walking towards the K1. Right, and then so you walk 1,000 metres plus 100 times by your birth month. So that will be 100 times by 6, 600 plus that. So I'll walk 600 metres towards K1, and that will get me to a point B. And then you take another measurement of the angle, and that's going to be 14 degrees plus your birth month, so that's going to be 20 degrees. All right, then you walk to the left towards the other road that goes towards K2, and it's going to be 200 metres plus 30 times by 6, so that's 180, that's 380 metres, right, between the two roads. And then you take another measurement at that one called point C, and that's going to be 16 plus 6, which is 22. So essentially that will be the information that you'll put in your diagram. Now, to help you with your diagram, right, if we have K1 over here and K2 there, so I start at point A, I do a measure, so you'll need to draw a right angle triangle diagram over here for that. Right, so this requires you to draw several diagrams. Okay, so you'll need to draw that diagram that goes there, and you'll have another point that goes there. So you've got your three-dimensional diagram there. Well, you've got your 2D diagram if you look from the side, and you'll have your 2D diagram if you look from the top. So essentially, these are your points, point A, point B, point C. So I would need to, if I was you, I'd be drawing my diagram that you look from the top view from. Alright, so you're going to have your point there, but you're also going to have your side view diagram. We're going to have H1, you're going to have A, you're going to have your point A, you're going to have this other point over here as well. Stop drawing for a second. So you're going to have this point here, that would be point B, then you've got point D down the bottom here, and you get your point A there. So, and you can talk about this one being the K1 diagram, and then you can label the information that you have on there to work out every side and all that sort of stuff that you need to do. So this one here would be the point A, B, D, and that would be point C, and then point E over here. And so therefore that's your top diagram that you're actually going to use. Alright, so you'll need to know obviously the distance of DE if you're going to work out obviously between the two top peaks. Now when we start looking at this from the side view here, we could imagine if we went across on a straight line, that's not very straight, but and then you've got that diagram there, So now you've got a triangle that you can solve with that's a right angle to work out the distance between K1 and K2 and see if it's feasible. Alright, so without giving it away, that's what you'll need to do for the diagram stuff. Now here are your constraints for what is feasible when you construct the gondolas. Alright, so you'll need to look at that information to make a decision about whether that will be a feasible thing to do. Alright, so keep that in mind. So obviously you have to show the calculations in part A using your diagrams. Feasibility of a gondola. Alright, so you'll talk about models about whether that can happen. So if you're just going to go from the top to the top, then is it feasible to do? And talking about constraints. You could also look at alternatives. So it doesn't mean that you'd have to go necessarily from the top on one mountain to the top of the other mountain. Maybe you could go a little bit below the top. Okay, and then you can have a ski lift that takes them up to the top there. So you look at a range of different models in terms of trying to make that possible. So that will be your job to come up with those creative ideas to try and get this thing to work. What would be the issue on a really bad day where the gondola is exposed to really extreme winds and so on? Well, maybe it has to be shut down. Okay, so maybe there would be an option of doing it a little bit lower to get out of the breeze. Alright, so there are things that you can investigate and talk about. Now keep in mind when you're investigating some of these things, you don't actually have to do it, you just have to talk about it. Alright, so it's about showing an understanding of it. So you don't necessarily always have to do the calculations involved with it. You can just do the ideas and you can talk about that. Now, limitations and effects of errors. So in this section, you need to be talking about what you're assuming to be correct. So you're assuming that the diagrams are all spot on, that the measurements are all spot on. So what sort of things would happen if your diagram was, say, a 1 degree out? What would happen to all the results? So 1 degree, when you're looking at quite a big distance, that might have a big bearing on the actual answers. So how about your measurement distances? So if they're out by 10%, how would that affect your overall results? So you can investigate that and talk about other things that we're assuming. So what are we assuming? Well, we're assuming the ground that you're taking your measurements from is flat. So most likelihood would be things like, well, it isn't flat, that it actually rises at a certain percentage to do that. Now, it might be tricky to do all of that sort of stuff, redo a lot of those calculations that you've done. So my suggestion here would be that you start using a spreadsheet for that. All right, so, and I'll provide you with a basic spreadsheet with the setup that I've got here. All right, so and then you can actually play around with the percentages and all that with that. And you could also use it for. So if you look at these things here, I've got labelled top view triangle. I've got K1 triangle, and I've got K2 triangle. So I've sort of broken it like that, and then I've got the overall summary, your final answers. All right, so now this will already have a distance in it. All right, so if we go section by section with that, I just enter that distance in. So I'm using my formulas. Over here, I've already set up a formula to work out AC, to work out your angle. So the formulas are there done for you. So you can certainly you'll be able to copy the information that you need there. When we start getting over here, we are using the sine rule and the cosine. Well, we're using the sine rule here to work out different angles, right? So that's what you'll be expected to do is possibly use a spreadsheet, because that would make life easy for you. Now, the great thing about this is I can then start looking at, let's say angle 15 is in fact really 16. So what happens there? Everything changes. All right, so everything changes in the spreadsheet, and then you can look at, what effect it does actually have. I can change that to be angle 17. Right, so what effect does that actually have on the feasibility of the project? So that initial survey, right, would be really important. I could then change that one to 14. And you notice that everything in the spreadsheet changes that relates to that section. All right, so that's the usefulness of that particular use of the spreadsheet. So you can do your what ifs and you can talk about the actual results rather than having to do all of those calculations again for each one. All right, get it there? So that hopefully will be useful for you. Limitations and effects of errors. So that's what we're talking about there. Now, the last part here is looking at the third mountain. So the third mountain is equidistant from the other two mountains, located so the gondola can go between the three mountains. What would be the maximum height and so on. So if we scribble some information about this particular thing, so just look from a top view straight away. So if we've got K1 or K2, and let's say it's going to be, say, there to make a triangle between the three of them, right? So you could start with a model where they are all equidistant. So if you know this distance over here, maybe it's 1,000 metres, then you can make that 1,000 metres. Right? So that's the first thing you can do. Now, obviously, for you to get your gondola there, right, you could be looking at, obviously, from the side view, is if that's 1,000 metres, you know, how high can this particular thing over here be? All right, in order to go from K1 to K3, and you could also do the same thing over here. You could make, it could be lower than K1, so it could be K1 to K3. So you can do some trial and error with that. Now, if that's using a set distance, you can also investigate that using a non-set distance. And all right, and then that would be the idea of using your, if we're going to do that, the idea of using a spreadsheet, possibly for that. So over here, you could have X and X. This is K1 and K2, and you might have that as 1,000. Right. So what could be the values of X there? All right. So keeping in mind, you could have that as an angle that would be set theta. All right. So this gives you an opportunity of using general terms. All right, so you know, doing it using a generalization. So then what you would do is you would use a spreadsheet. You'd have your theta there, you'd have your X value there. All right, so you might fix the values of X. You might fix it to be 1200. If that's the case, then you could work out what theta was based on that information. And or you could do it the other way around. You could fix the angle theta. So you could say that was 20 degrees, and then you could work out what X was. So that last part allows you to play around with the formulas that you do know and do some different models. So the key concept there, you will look at the horizontal distance between the two, and then you'll be looking at how that translates into the vertical distance. This is probably the most complex part of the whole investigation, so that will require a little bit of extra work for you. Now, keeping in mind you have your document, it sort of goes through here the sort of things that you need to better do that I'm looking for when I'll be marking it. Alright, so each of the points in there basically ask you to show what you're doing there. Obviously, going to your performance standards, you can see what you need to do to get an A and so on. Now, obviously, the report needs to flow as a logical piece of work. So you must hand up a complete report which includes introduction A, right, the results for all your tasks, analysis and discussion, including all those things there, and a conclusion summary. So you'll be making a recommendation based on whether it's feasible or whether it's not feasible. that will be depend also on what number you start with. Okay, so if you're a 1, 2, 3, maybe it works. Maybe if it's a 11, 12, it doesn't work, or it might be the other way around, that it works for 11 and 12 and it doesn't work for a 1, 2. So it will be different results depending on what your starting number is. The key thing for any report is to make sure it's a logical piece of writing, and we'll show you some exemplars of a good report and a bad report. I suggest when you have all your working out that goes into an appendice, and then you're using summary tables and a sample example of the calculations in your main report. So when you're doing lots of repetitive calculations that can sort of just get in the way, still want to see them, but they're not really crucial. They're crucial in the fact that we need to get them right and all that, but if you're doing repetitive calculations, then it's good to maybe include that to show that you actually done it. But really in your main body, we're looking for the summary stuff. That's what we're looking for. So what you do is you say refer to the appendice number 1 for these calculations, refer to appendice number 2 for these calculations, and then what you'll do is just summarise those results into a table, which is a really useful way of making sure your whole project is logical and precise. Just the other thing that you need to keep in mind is you don't have to write heaps and heaps to get a good mark. Right? So it's about writing precisely and getting to the point. Right? So because yours is 5-6 pages long and someone else is only 2 pages long, doesn't mean that you're going to get a better mark because you've done more work. Doesn't work like that. We're looking at quality thinking, quality writing, quality explanation. Not to say that if you did 5 pages of really good high quality work that wouldn't be useful as well. So that's really important, that you try to extend yourself, looking at critical thinking, looking at showing a really high understanding of the concepts and how the mathematics relates is really what we're looking for you to do. Right? To be critical of things like errors. That's really, really important when you're looking at that. But it should flow as a whole piece of work, and it should be easy to read for whoever's doing that. Now, obviously, as you're working through this, we're going to have a deadline point where you will be able to submit a draft. Up to that point, you'll be able to get help all along the way, which I think will be useful. So what will happen is once we've had our deadline for the draft, that's what you submit, and then we'll give you a feedback on that particular draft, and then we'll give you a week to actually correct those and then submit your final product. And so we'll be expecting you to do this also electronically and submit this on Daymap. That will be crucial for you to do that. All right, hopefully this has been useful. Obviously, you might need to watch this video a number of times when you're getting up to certain sections, but I hope it gives you a bit of an idea about what you need to do and what we expect.